Nice. So this is the worksheet for nomenclature on ionic compounds. So we actually kind of did a lot of this. I did a little extra on that first worksheet and going over the naming conventions. Um, but we're going to go do some more practice. So to name it, first the cation goes first, right? And then the anion. So typically you're going to have a metal and a non-metal. That's not always true, as we saw, right? Like ammonium with something else. So the cation is the positive one. The anion is the negative one. It's helpful. My teacher once said cats are positive. Kind of a terrible pun, but it's the only thing that helped me remember. So cations are positive, and then the anions are the other one. Two, it says when the formula unit contains two or more of the same polyatomic ion, that ion is written in parentheses with a subscript written outside the parentheses. So we actually saw a little bit of this, right? Where I had to put parentheses and then put a subscript to show that these polyatomic ions were all, there's multiple versions or multiple of them, right? They didn't just, you don't just add the nitrogens and oxygens because that changes the composition, which changes the chemistry. So we said that there's four of these different polyatomic ions or whatever it may be attached to this whatever one thing. Three, it says if the cation is a metal with a fixed charge, you just name the cation as the neutral element, so like lithium, sodium, blah, 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 calcium, all that fun stuff. The cation is a metal ion with a variable charge, so typically those transition metals that we saw in the last one, right, with like nickel, manganese, lead, there's a lot, tin, pretty much all that middle block for the most part is going to be things that can have a variable charge. And then we denote it in this parentheses, right? No Roman numerals as we saw. So iron 3 plus is iron 3. On Alex, I think they were being picky that you can't put like a space or something. But really it's the same thing, space or no space between the parentheses and the name. Four, it says if the anion is a monoatomic ion, the anion is named by adding the suffix "ide." If the anion is polyatomic, the anion is named by adding the suffix "ate." So if it's just right like a monoatomic ion like fluorine, so sodium chloride, sodium fluoride, right? Just fluorine, fluorine, bromine, bromide. You add "ide." If it's polyatomic, you put "ate." So sulfate, phosphate, nitrate, right? Those were all polyatomic ions that we saw. There are certain exceptions depending on the oxidation state. Yeah, so there are some exceptions, right? But this is the general rule. What types of elements are compounds composed of? So, or ionic compounds. So ionic compounds are composed of a metal and a non-metal, right? And we saw this in the first worksheet when we were defining things. So ionic compounds composed of a metal and a non-metal. What charge does a cation have? So a cation has a positive charge. This means that the atom loses an electron, right? So the less electrons you have, the more positive you are, because electrons are negatively charged, right? So on the inverse, anions have a negative charge because they gain an electron. Right? So positive charge, lose, negative charge, you gain electrons. Number three says between the elements given, identify which ions are a cation and which ions are an anion. So the cation, or which ones are cations, which ones are anions, right? So cations are the ones with a positive charge. So calcium 2 plus, NH4 plus, Fe2 plus. These are all cations. Ag plus, that's silver, aluminum 3 plus, and then H3O plus. Those are all cations, and then we have anions. We have Cl minus, I minus, OH minus. That's hydroxide. That's how we refer to it. Cr2O7, 2 minus. This was dichromate. SO4, 2 minus as our last one. These are all anions, the ones with a negative charge. 4, it says write the name of the ionic compound based on the given formula. So this first one, we have aluminum, Al, right? You can look at your periodic table for that. That's how we would find these. Aluminum chloride. Now, I would recommend pausing the video and working through these yourself and then checking your answers, right? And the explanations after. So aluminum chloride is monoatomic. So chlorine is monoatomic. So we say chloride, not chlorate. CaBr2, this is calcium, looking at the periodic table. Bromide, because bromine is monoatomic. Right, notice here too that with the covalent, we had like dibromide and stuff like that. Here we don't. So here we just say it like normal, right? Only in the non-covalent, or sorry, the covalent compounds do we say like dibromide, tribromide, tetra, or whatever. These we just put the normal name and then an I or 8. So this other one is lithium from periodic table again, that's the Li. CO3 is carbonate, right? It's polyatomic, CO3. D is sodium nitrate, Na for sodium, NO3 for the nitrate. And nitrate is polyatomic, so 8 at the end. And then this last one is barium phosphide, right? Phosphorus is monoatomic. Now, if you're asking yourself, well, this is 2. That's not monoatomic. There's multiple ones. Right? We're referring to this whole thing together. So individually, right? There's 3 different fluorines attached to this aluminum. Those are monoatomic. Those are by themselves. Right? There's 2 different bromines attached to the calcium. Those are monoatomic. The CO3, this is a carbon with 3 oxygens that is attached to the lithiums, right? That's polyatomic. So same with this phosphorus, right? There's 2 different phosphoruses, right? They're not just together. So that's why those are monoatomic, right? There's just one atom, essentially. That's being bonded like individually. 5, it says write the formula of the covalent compound based on the name given. So sodium chromate, you have Na. If you're looking at your sheet, chromate is, I believe it's CrO3. I am going to double check this very quickly. Chromate is actually Cr2O4. So, and that is a 2 minus. So this is going to be, so let me write that here. Chromate is sorry, not Cr2, CrO4, 2 minus. So sodium chromate is, right, we have sodium at a +1. We have chromate at a 2 minus. So this has to be Na2, CrO4. I need 2 sodiums to balance out with the 2 minus on the chromate. I think on the answer key it says Cr2O7, that is dichromate. So this is just normal chromate. 2, or B, it says magnesium sulfide. So magnesium is always a +2. Sulfur is always a 2 minus, generally, unless it's like sulfate or something. But generally speaking, sulfur is going to be 2 minus. So MgS. Potassium iodide, right? 1-to-1 ratio. Potassium iodide. Potassium is a +1. Iodine is a -1, so it's just Ki. Right, I don't have to do anything special. Ammonium chloride. Ammonium is NH4. Ammonium is at a +1 charge. Chlorine is at a -1 charge. So it's going to be NH4Cl. I don't have to add extra of one or the other because the charges balance out in a 1-to-1 ratio. This lithium phosphide. Lithium is at a +1. Phosphide is at a 3-. So I need 3 lithiums, right? 3 +1 charges to balance out with a 3- charge. Now that is it for this worksheet. I hope that helps, and I'll see you in the next worksheet.